I thought it might be time for an Ice Giant update, because I did the video on the failed closed loop coolers a little while ago, and more of those are on the way, because I'm a glutton for punishment apparently. Well, the system behind me is the Ice Giant system with the 64-core Threadripper. Not Threadripper Pro, but Threadripper. And that's got the Ice Giant cooler. I've been using it for about a month, and with PBO turned on. Initially, I wasn't running with PBO, but I had a chance to sit down and chat with Jim Pryor when he's repping Ice Giant, and we had a really good chat. And so he's like, "Oh yeah, I run it all the time. It's completely okay." So I put it to the test. I've been running it for about a month, doing rendering jobs and background jobs and just all sorts of really super heavy compute stuff. The CPU is consuming north of 400 watts most of the time, and the Ice Giant cooler handled it completely fine. I've got the side off now because of the glare, but that is a system based around the Zenith Alpha 2 Extreme from Asus, and I have a GCL Trident Z memory, and I have no complaints whatsoever about the Ice Giant. It does the job, and it does it beautifully. One particular oddity, though, is with that Asus motherboard, some of your M.2 are on a DIMM.2 add-in card. It adds in, and it's a little taller than the regular memory modules. That doesn't clear the Ice Giant. It's a little bit of a compatibility issue between the Ice Giant and that particular motherboard. Now, of course, I can get an add-in card and run my NVMe and a PCI Express add-in card that does take up PCIe slots, and it does have some other onboard M.2, so that works fine as well. Of course, I'm rocking the 3060 Ti, the really, really fancy, colorful one. So anyway, the Ice Giant, super impressive. Definitely would recommend it over an all-in-one as long as clearance issues are not really the thing. And he hints at possible futures where, hey, this will actually work on a rotated socket. Because keep in mind, even though this cooler is sort of a giant, amazing cooler, it only works in certain orientations. You can use it horizontally in a desktop, or you can use it in this tower configuration, but it doesn't work if it's rotated 90 degrees. That's because there's no pump in it, and it relies on gravity to return the condensate back to the cold plate. It works really well. It's a Thermo-siphon. It's not exactly a new technology. It's been used in industrial processes forever. But, here's the interview that I did with Mr. Jim Pryor, and it was awesome. And so if you're curious about all things Ice Giant, check it out. I've got another month of testing in, and it's pretty awesome. All right, I've got something very special today. I'm joined by Mr. James Pryor of Ice Giant. But also, I mean, do we talk about the other thing?
Now we'll just talk about this one today.
Okay, that's fine. You have your hands in so many pies. It's honestly very exciting for a lot of reasons. But you saw my Twitter post. I got a Thermo-siphon. I wasn't sure what to expect, but I got a Thermo-siphon for my 64-core Threadripper monster, which I'm now able to run with PBO. But I don't have to use a custom loop with it anymore, which is honestly very impressive.
Yeah, very impressive. That's what I'm running on mine. I have a 64 core as well, running PBO. I think I'm sitting around 525 watts is my day-to-day setting.
I haven't pushed mine that far, but that's impressive.
Yeah, it's all about the air temperatures. It's heating up in here in Texas, so I think that probably my summertime one. During the wintertime, I was closer to 625 or 600.
That's a lot of, well, I mean, it is 64 cores, 500 watts divided by 64 cores. It's still not a lot of watts per core.
No, it really isn't. It's just a tiny little bit per core, and it all adds up very, very fast because you've got that 64 times multiplier.
So a Thermo-siphon is a little different than, well, it's a lot different than a tower cooler, and it is completely different than a custom loop cooler. I mean, with custom loop cooler, you've got a water reservoir and a pump to move things around, and then the water heats up on the block, and then it goes through the reservoir, and then the radiator and the pump, and it cools off as it goes through the radiator, and air is passed through the radiator. With a Thermo-siphon, there is a phase change material in there, I guess, or what's going on there?
Yeah. So inside the pipes, we do have a phase change material. It's a refrigerant-like kind of fluid. So it boils off of the hot plate and evaporates, goes into the condenser, and it's got this clever little one-way loop, right? So you've got this constant convection and cooling and heating and evaporation and condensation loop, and that's how you transfer the maximum amount of energy, right? Because that's the big energy release when you boil, and the big energy absorption when you cool off, and that's how you get the transfer of energy and heat from the processor through to the fin array where the fans whisk it away. So we've got that patented technology on that one-way loop, which is powered by gravity. So there's no pumps, no maintenance. It's fully sealed. You never have to worry about it, and it's got a 10-year warranty, so that you can just, the only thing you're going to replace is the fans. Just keep it clean and keep the fans spinning. That's it.
I have a cat, and that's really hard because the cat makes a lot of dust. So I don't know if I can keep it clean, but I'll try.
That's all we ask is the best effort.
Now thermosiphons are not exactly a new technology. I mean, I've seen thermosiphon type cooling technology on industrial equipment, but it's if my memory serves, that equipment was much bulkier. So I'm really surprised that we're able to shrink it down into something sort of usable on a desktop computer.
Yeah, that's part of innovative technology and design, is that we're able to shrink something that's been around for decades and used in massive industrial applications, extremely reliable, proven, and take it to new spaces such as personal computing and data centers and things like that. It's part of the advances in material science. It's part of the advances in our designs and our super smart engineers. So that's the big change that we've been able to make, is the miniaturization, the engineering effort, and bringing it to the computing space.
I think also a big advantage of the thermosiphon has is that it works really well when the heat is not concentrated at a single point. And with like the chiplet architecture of Threadripper, you've got a lot of hot spots, and so it's sort of a lot of hot spots over a larger area, and it seems like that also works in favor of the thermosiphon.
Yeah, the type of cooling we've got, being gravity driven and being based on the thermosiphon technology, lends itself to high TDP applications, right? And we're scaling it down. So from the kilowatts of power of electric motors and pumps and all those kind of things, down to the mere hundreds of watts of Threadripper and big chips, right? It's really likes the bigger amount of heat. Now, what the benefit there is, this design started off aimed at Threadripper. It was, aligned to that use case from the get-go. So that's why you see the best possible performance out of the design with multi-chip modular architectures, which just happens to be the direction that the industry is going in, is that everything's going to be multiple chips. So
what you're saying is when Adler Lake turns out to be 28 nanometers and 73 chiplets come this fall, and it's 800 watts, the thermosiphon's going to be right there to deal with it.
Yeah. So we've got the scalable technology. We can add in, more heat pipes and condenser pipes to go across the base and just the size, depending on the needs of the platform. So it's all opened up. So we're just starting off with consumer PCs and high-end desktop, because that was the easiest, most obvious place to demonstrate the advantage, and a place where we had significant differentiation with not only being able to be a set and forget with higher reliability, but the amount of cooling performance you get for the price.
Yeah, cooling performance, and the fact that it is essentially solid state. I mean, I guess it's not technically correct to call it solid state, but it's pretty much solid state.
There's nothing to fail. There's no moving parts. I mean, you don't call the wind a moving part, so you don't call is a pot boiling a moving part? I don't know. It causes something. If you put a fan or a wheel above it that would spin, that would be a moving part, but you're not, right? So it's all self-contained energy transfer. That's no moving parts, and that drives massive reliability, which is what people want, because then you don't have to worry about failing pumps and gunky liquids and goop buildups, stuff like that. All the usual worries for if you just want to set it and forget it kind of build, like in the workstation and professional audience that really enjoys this thing.
Yeah, I've got mine in just a regular, I would say almost pedestrian. It's in the Fractal Meshify 2, and it's a perfect fit. Like it's got that movable drive bay thing, and so I slid that to the front, and there's probably only about 3 millimeters of clearance, but in that configuration, that case can hold like 14 drives, and there's plenty of room around the processor. I mean, I'd have to take the thermosiphon off to change the memory, but there's still plenty of room around everything else in that case, and because I can pop the top off of it, I can still still get to the top of the motherboard easily, even though the Thermo-siphon is just right there in the top. I can still get to all the connectors and everything. So it's worked out pretty well. And the performance really speaks for itself. I mean, I had this system on a 360 custom loop, and I switched to the Thermo-siphon because I needed the custom loop on Threadripper Pro, and it is every bit as good, or maybe even a little bit better than the 360 millimeter custom loop. I mean, it really is that good, and that was the part that was surprising.
Well, I'm glad you like it. That was our goal, is to compete with that level of cooling, because that's a much more significant cash investment as well as time investment, skill to know how to build it, or to, buy it from a boutique builder. So there's definitely an opportunity for us with those style of builds. And yeah, the condenser is huge and big, because we wanted the first prototype had 2 fans on it and was this big bulky chamber, but a lot of it was just we were trying to figure out how much we needed, and then shrinking that down, we were able to get an extra condenser in there and put in more fans, so you could run lower speed for quieter noise, but also have the same level of performance. And it covers the memory slots and it covers everything else. But there's been 2 schools of thoughts, right? When there was not a lot of differentiation in PCs because everybody was using the same CPU, the same GPU, then everyone was trying to figure out, how do I make my build different? And the answer was blinky colored lights. Now there's a few more different options. You got, the number of cores, the amount of memory, the number of PCIe lanes, lots of different ways to show you have a different focus for your build or your workload. And maybe there's this strong growing community of people that say, I just want cooler that works, and if I want to put lights on it, I'll figure it out myself, thanks.
I really want to figure out how to mount this thing on Threadripper Pro. I have a feeling that's going to involve me 3D printing some desk feet for the Fractal Meshify 2 and just use the case horizontally and then be like, yes, this is my workstation. So. Yeah,
you could do that. Or go full, get one of those open bench tables and go full open bench and just set it out. I don't know. There's the rotation of the socket kind of interferes with the current design, but future designs, we've got a plan in place to be much, much more compatible and solve all of this. But it's right now the focus is scaling up production, getting more of them out there. That's why we're super pleased that we're now in select Micro Center stores on the shelf in store, and that's a really great thing for us. We're also expanding in Europe with Case King, so greater availability, more and more volume is helping to get us growing, and we can learn more about what we need to do for the next generation. But right now it's all about getting this first generation off the ground.
Are you aware of anybody else using Thermo-siphons with the 8380 Platinum Xeon from Intel?
I've not heard of that. No. That would be. I'd be really interested to see how that goes.
I'll let you know.
It should have all the performance, but that's a hot die in a central point. So our aluminum base plate is better for the multi-die stuff. We need to go to a copper design in that base plate to get the max out of a single die.
That's still a lot of silicon real estate. I mean, there's a lot going on there. I've got a couple more prototypes I got to make out of on the 3D printer, and then I'm going to try to machine it on aluminum, a little bracket thingy, but we'll see how it goes.
Yeah, I'm excited to see how that would look and fit together. That would be that'd definitely be fun.
I know I can do 1. I don't know about 2. I may have to only be able to use the motherboard in a horizontal configuration because rotation, like getting everything crammed in there, sort of becomes a little bit of a challenge.
Yeah. Well, that's the fun about living on the bleeding edge with skunkworks projects and building all the fun stuff that nobody else wants to build. Is you find stuff out.
Let me see if I can pull up some of those questions. We've covered literally everything. One of them was, will the NVMe DIMM module work on the Zenith? And I have not gone back to check that yet.
No, that one's a little too tall, unfortunately. Both the Zenith and the Zenith 2, but because they have that new one that had the heatsink cover on it, as well as the first one, which was just the bare. It's the little flanges at the end. They have that little design where it spikes up. If they hadn't put that on there, it would fit. But because they put that little I don't know, the little wings on the end. That's what blocks it from being used. So personally, I just use the Asus PCIe card that puts 4 M.2s and turn on the bifurcation for NVMe RAID mode, because I've got 6 NVMe's in my Threadripper system. I just don't use the little memory DIMM.2 slot.
Yeah, that makes sense. And that motherboard also has an M.2 on the back, which is not super convenient.
No, but you can populate that board with a ridiculous amount of devices. So I think probably better is just use the add-in card, because that way you get airflow across all your drives.
Yeah, you need that too. Yeah.
If you're going to put the Mac Mini on there, you're probably using a RAID set, and you probably need to have them all cooled, and that one on the back's not going to get as cooled as all the others. So, yeah, they used. I didn't think it was possible to cram that much onto an extended ATX board, but they certainly left no stone unturned.
Yeah, that's very true. I've got the Threadripper Pro system. I've crammed 29 NVMe into it. I'm out of PCIe lanes. It's a video card and then the entire everything else, 116 lanes of PCIe.
I approve.
Initially, the BIOS crashed when you had more than 10.
Yeah, that was scaling up that number of PCIe devices takes a little bit of work in the BIOS.
Yeah, I don't think they planned for that. Since I did my video on the Pro-Siphon build with the 64 core, a lot of people have popped up and said, "Hey, I got one of those and it's worked out pretty good." If you pick up one, or you've already picked up one, post your pictures in the forum at Level 1. And we sort of talked about like the Threadripper Pro, and like there may be another version coming, and we can't say anything about that one yet, but we can tease something else. What do you got for us?
Yeah, so I'm sure you've seen that we use the Arctic cooling fans on the IceGiant, and those were slightly different from the standard ones. We worked with Arctic to get the fan speed range increased a little bit, so they go a little bit faster. And then we're going to work on introducing that same modification to their RGB fans. So there's going to be a colorful, illuminated blaze of RGB direct into your eyeballs version of the IceGiant as well, if you so desire. So watch for that coming soon.
Will you, if the RGB version sells better than the version that you have now, will you join me in weeping for the future of humanity?
I don't think it'll sell better, but I think people will enjoy it. But we'll keep both of them running at the same time, so we can let the market decide what is the future.
What's the difference between these two products? Well, this one has blinking lights, and the other one is just quietly awesome.
Yes, this one is audaciously awesome.
Well, it's been awesome having you. I'm glad that you could join me for this video, and I always like looking at new technology and new products. Here's to the continued miniaturization and improvement of IceGiant technology, because I like the cooling capacity of a custom loop, but I also really like the simplicity, and it's not going to fail and spray water everywhere, of a tower cooler. And this marries both worlds, which is always a great thing in terms of technology.
Yeah, for sure. That was the goal, is to get those things married together and to bring that to the market. And we're really excited that it's worked, and can't wait to get to more success so we can do more.
Nice. Well, it's been awesome having you. Thank you for taking time out of your day to join us. And we'll take a look at the RGB version just as soon as it gets here, if I don't get it working on the dual 8380 first.
For sure.